All right, what's up, Joel? Okay, so today you're going to be learning about finding the area and a perimeter, the area and a perimeter of a shape on a coordinate grid. It's going to pull back into those things that we've learned about in the past, is the distance formula that right here that you learned about last week on Friday, I believe. Pythagorean theorem you've learned about in the past, and then the area of a rectangle. You also might need the area of a triangle today. As well, which is just going to be 1/2 base times height, right? So let's kind of go through this process. I went ahead and erased my notes, and I'll kind of go through this slowly showing you different things. So the first example here says, find the perimeter of the figure, give the exact answer to answer rounded to the nearest tenth. So if you're looking here, they're not falling right on lines, and so we can't use our ruler theorem, but we can use our distance formula, right? Because we have the distance from one point to the next. So first thing you do is that you have to identify all points. And so the first point that I'm going to identify is h, which is at -2, 0, and I, which is at 3 and 2. Because what I want to do is I want to first find the distance from line segment H to line segment HI, right? And so what we do is we slowly fill out those pieces into our distance formula, and we still do the exact same formula as our distance formula. So label your x1, your y1, your x2, and your y2, and plugging those pieces into your formula, right? And you're slowly going to solve that. So 3 minus -2 is going to give you a +5. Square that, you're going to get 25. 2 minus 0 is going to give you 2. Square that, you're going to get 4. So you are here. Add those together, you're going to get 29. HI equals the square root of 29, and you're going to get your answer, okay? But you also have to do it to the other side too, because we have another sine length. And if you're thinking about perimeter, you're adding up all of your sine lengths together, right? And so let's go ahead and find the second one here. So I first have to identify my I, which is already at 3, 2. And then I went ahead and went with my J, which is at 4, -1. And so what you do is, again, you plug those points into your formula. Again, it doesn't matter if you choose x1 first or y1 or x2 first, as long as you keep it consistent on both sides. 4 minus 3 is going to give you 1, which is going to be 1 squared, which is 1. -1 minus 2 is going to give you -3. -3 squared is going to give you 9. 1 plus 9 is going to give you 10. So your answer for this one will be 10. Now, the reason why I have 2 times the square root of 29 is because we have 2 lines that are the same distance, right? We're looking at a parallelogram, which means you have 2 sets of parallel lines. HI is parallel to KJ, and so that's why I'm doing 2 times the square root of 29, because they're going to equal both 29, the square root of 29, right? Also, with the square root of 2 times the square root of 10, the reason why I'm having 2 times square root of 10 is because I have 2 lines that are the same distance, right? I to J is the same length as H to K, so I'm doing 2 times the square root of 10, so I can get the measurement of both those lines together, because they're going to be equivalent, right? So after that, I went ahead and turned it to decimal form. I would like you to change it to decimal form too. So your perimeter is about 17.1 units. Okay, let's go ahead and scroll down and look at a perimeter of a triangle. So this one's going to be a little bit different, because instead of having parallel lines that are congruent, we now are going to have 3 separate lines that we'll have to do it for. So our first line I'm going to do is from D to E. So -3 to 3 is D, and then 5, 1 is E. So again, you're just going to plug these into your distance formula and slowly solve. 5 minus 3 is going to give you a +8. 8 squared is going to give you 64. 1 minus 3 is going to give you -2. -2 times -2 is going to give you a +4. 64 plus 4 is going to give you 68, which is going to be about, and you can change that to 4 times 17, which is going to be 2 to the square root of 17. Now, I also don't care if you change those to decimals. You can change those to decimals if you don't like working with the square root sign. You'll also do it for the second line, which I'll do D to F. So D is -3, 3. F is -4, -1. Again, label your x1, y1, x2, y2, and plug those into your formula. So -4 minus -3 is going to leave you with a -1. -1 times -1 is going to leave you with 1. Negative 1 minus 3 is going to give you a negative 4. Negative 4 times negative 4 is going to give you a positive 16. 1 plus 16 is going to be 17, which is square root of 17. All right. You also have to do it for that last line here. So F to E is the last one we haven't done yet. So negative 4, negative 1 is F, 5, 1 is E. Again, you're going to plug those into your formula and solve, right? And slowly work through just like we did, 81 plus 4 and square root of 85. Now, with these ones, we're just going to add them up. So 2 to square root of 17 plus square root of 17 plus square root of 85. Again, I do not care if you just do decimal form. You are more than welcome to change those to decimals, which I did here, which is the perimeter equal or is equivalent to 21.6 units. Okay. If you have any questions on how to find perimeter, please let me know. All right, let's scroll down to our last little example here. We already did perimeter, but now we need to look at an example of an area. So find the area of a figure, give the exact answer, and the answer rounded to the nearest tenth. All these are going to be rounded to the nearest tenth, just so you know. For this one, it's going to be very similar to the first question, same process, but the last little piece is different. So again, you're going to identify those 2 points of your first line. So we're going to go ahead and do T to U. And slowly, again, walk through that process. Plug in your numbers, x1, y1, x2, y2, and slowly solve, going through that process until you get your answer, okay? Again, you have to do it for your second line as well. Plug in those numbers into your equation, slowly solve across until you have your answer. Now, the only difference with this one is that because we're looking for area, we're not going to use the distance formula. We are going to use the area of a rectangle. So base times height. Okay, so you're just going to do 2 square root 2 times 7 square root 2 to get your answer because we are using base times height, right? And so when we do this, the area equals 2 to the square root of 2 times 7 to the square root of 2. And your answer will be 28 units squared because we're doing area. When you're finding area, your units are always squared. Don't forget that. All right. Well, I have the answers for the rest of these here. If you have any questions, please let me know. This one's a little bit different, right? Rhombuses have all equivalent sides. So you only do it once, but you're going to times it by 4. The rectangle, again, just like my example I showed you for the first one. Down here, you're doing area again, so don't forget about, oh, well, this one's perimeter. You're doing area here. Polygon, you got a triangle, you got a square, or a rectangle. You got another polygon, you got another area here. So if you have any questions, let me know. But slowly work through these. I have the answers here for you if you want to just check them. But try to do them on your own first, obviously, and go from there. If you have any questions, let me know. Have a great day, Joel.